Hey guys, welcome back to Tekneikos. This video is the first for the Kubernetes series and I'm going to teach you Kubernetes from very basics to advanced, and we are going to deploy 2 to 3 applications within the Kubernetes. So I can guarantee you are going to learn a lot of things. If you are going for a DevOps, cloud or SRE roles, this is going to be very useful. I am working as an SRE and I can guarantee you whatever I'm going to teach you through this series is going to be 110% useful for your career. Okay, now maybe we can start. So why should you even learn Kubernetes? This is the question I'm asking you. So if you deploy apps on servers manually, you are already outdated. If you use Docker but you don't know orchestration, you are incomplete. And if you want to work in DevOps, SRE or cloud, this is must. Although you might not be using K8s on your daily job on a daily basis, but this is important because modern apps are transforming to microservices, and each microservice requires a container, and you cannot deploy hundreds of them using Docker or using any tool apart from an orchestration tool. So this is why you need Kubernetes or K8s. So today I will be explaining you Kubernetes architecture so simple that you will see it like a company hierarchy. Okay, before we go into Kubernetes architecture, we need to understand few things. The first one, of course, before Kubernetes, how things used to work. Before K8s, how things used to work. Because it's not like from day one somebody just thought let's just deploy something on Kubernetes. Okay, so there's a huge process, huge ways of improvement happened before Kubernetes. So the stage one was bare metal servers. Now what is this bare metal server? It has one physical server. You know what is a server, I guess. If not, let me explain you what is a server. So a server is a system that provides resources, data or services to other systems over a network. Okay, that's it, very simple. Or you can say a server is a computer that responds to requests. So a server must have one operating system. It has one application deployed. Okay, now take a scenario where if the server which is running our application crashed, okay, what will happen? Application gone. It's gone. Just you cannot access your application. Your people who are using your application cannot access it anymore. So it's a huge loss. And suppose we want to scale it. You want to scale the server. You need to buy a hardware. Again, you have to buy it, and then only you can scale it. It turns out to be a slow plus an expensive process. Definitely you can say we can do a vertical scaling or horizontal scaling. That's a different case. But if you want to scale in general, you have to spend a lot of time. So it's slow and it's expensive. Okay. Now let's come to the problems that we have faced in a summary using a bare metal system. It's a waste of resource. It's having no isolation. It's having no elasticity, which means it's not scalable much. Now the second way of deploying your application is a virtual machine, or the second stage we can say a virtual machines came into picture. Now here is where the picture gets more clear. A virtual machine, we have to understand what is a virtual machine first. It's a software based computer that runs inside a physical computer. Okay, so there you have a physical computer, and with the help of some software you are running another computer inside it. Okay, that's called a virtual machine. It behaves like a real machine. You will feel it's machine 1 and this one is machine 2, but actually it's inside a real machine 1. It behaves like a real machine. It has its own operating system. It has its own operating system like Linux or Windows. It has its own CPU, RAM and storage, but all are virtual. These all are virtual. It's not real. It's what you split from the real machine. In reality, it's just a program running on a real server. Then how do you achieve this? If you have any doubt, so then we are achieving this using something called a hypervisor. So we use something called as hypervisor, although this is not a topic of this video, but as a context I have to explain these things to you so that if somebody asks you, you can able to answer. So a hypervisor is just a software that creates and manages virtual machines. So its job is to, I hope you are able to understand this. Its job is to divide CPU, RAM and your storage. It helps you to create multiple virtual machines. It isolates them. Now, your biggest problem in the bare metal system that you were facing is isolation. Using the virtual machines concept, you are able to eliminate that. So this hypervisor isolate them from each other. Okay, I hope you are clear. So in one virtual machine we can deploy multiple applications. So this used to be a very good solution back then, and now also some people prefer this as well, because still if your organization is not able to pay the bill of Kubernetes, which is or cloud servers, some small startups use this VM technique, because it's still your applications are isolated. One VM crashing does not affect others. Better resource uses. Okay, but here's the problem with the VMs. Each virtual machine needs a operating system, a full operating system. Each one of them takes GBs of memories. Each one of them boots slowly, and it's heavy when it comes to resource consumption. These are the 4 big problems that we face when we deploy something using a virtual machine. In a very small organization where you have 1 or 2 applications, that's fine. But if you are running 20 virtual machines, then think of it how much resource these 20 virtual machines are going to take. Okay, that's very inefficient. Now finally we are at stage 3, okay, where we use Docker containers or containers concept. Okay, this is very important. Specifically I'm pointing to Docker because it's widely used. So a container in general is a lightweight package that contains only, when I say only, it's literally only your application code, the packages or libraries it requires, we can say required libraries, and it has a runtime environment. So this runtime environment needed to execute the code. Okay, with only these 3 things you can able to run your application. It runs directly on the host operating system. So there's a host operating system, you can have multiple containers. So what is a Docker? They understood the container. Now what is Docker? So Docker is a software or a container platform that builds and runs your containers. Okay, it helps you to build what I said, and it helps you to run those containers. Think of a Docker as a tool that makes containers usable. Now, how it is different from the virtual machines? How it is different from a virtual machine? So if you can able to remember, I told a point. Each virtual machine, each VM uses operating system, its own operating system. It is very heavy, it is slower to boot and run. Now compared to a Docker or container, it's lightweight. Bear with my handwriting. It does not use any extra operating system apart from the host operating system. It's very lightweight. It starts in seconds. Okay, so virtual machine virtualizes hardware, containers virtualizes the operating system. Okay, so we saw VMs making or virtualizing the whole hardware. We saw we have a hardware and we can have a multiple containers which is virtualizing your single operating system. Okay, I hope these three things are very clear to you. First we saw the bare metal servers, then we saw virtual machines, then we saw Docker or containers. Although Docker has already resolved a lot of problems, but it could not resolve one more issue. Docker solved packaging problem. Okay, Docker has solved packaging problem, but it did not solve the management of those packages. Okay, suppose for instance if you have 100 containers across 10 machines, and those 10 machines, those containers need auto healing, or it may need scaling, or need load balancer. It's not possible with Docker. It's not possible. For that you need something orchestrator tool, and there the story comes to stage 4, Kubernetes. Think Kubernetes as the CEO of infrastructure. Kubernetes does not run containers directly. It manages clusters of machines. Okay, so what do I mean by this term? It manages clusters of machines. So we can say we have a cluster. I will explain the architecture, then it's going to be very easy for you. We have a machine, we have containers, we have Kubernetes. This cluster is group of machines. This machine itself is a node, okay, or nodes. This container packaged application, okay, that needs to be run, and this Kubernetes is the brain or CEO of infrastructure. It manages all of these things. So finally we are ready to see the Kubernetes architecture and understand this in depth. So I will write K8s architecture. So suppose this whole black box is your one cluster. Okay, so a cluster is a group of machines working together to run your application. Inside a cluster, so I can mention here, this one is your K8s cluster. Okay, inside your cluster we have a worker node and a control plane node. Okay, control plane node, we need to make a control plane node out of it, and inside this we are going to make all the control plane node components. Okay, so this one is your CP control plane, and I will make a similar, calling it as a worker node. At the end of the video I can guarantee you can able to explain the Kubernetes architecture to anyone and even make it by yourself. So we have a cluster, inside that we have a control plane and a worker node. So the control plane is the brain that manages the cluster, and the worker node is the machines where the applications actually run. So we are going to start with the control plane. So we are going to make the components of control plane node. Okay, what we have seen in the OpenSourceify website. Let me open that again. If we go to courses and then Kubernetes, I guess architecture, yeah, so this is what we have seen. So we're going to make this here. So the first and the most important component is API server. So what this API server does, it acts as a central component that exposes the Kubernetes API. Okay, in the main communication gateway of the cluster, every request, so each request that you make to the control plane, whether it comes from the user which is using kubectl command, you will be using this kubectl command in your terminal, and or from automation tools, or from the internal Kubernetes components, any components must pass through the main component of the Kubernetes, which is API server. So every request has to pass through this. It validates request, it checks permissions, and then stores or retrieves information from the cluster database, because every component communicates through it. So API server acts as a central coordination point of the entire system. Now this component might need something to store some data. So we have a database. called etcd. Okay, so this etcd is a distributed key value database. It stores the complete state of the cluster. It contains information such as what application should be running, how many instances should exist, configuration settings, network rules, and node details. Kubernetes continuously reads from etcd to understand the current cluster state and compares it with the desired state defined by the user. So this is a very crucial database in Kubernetes component. Now comes the scheduler. So we can make a scheduler here. So this scheduler is a component responsible for assigning workloads to nodes. Okay, you're going to understand this. Decides where a new pod should run, when a pod is created. You are going to understand what is pod. Okay, the scheduler evaluates all available worker nodes and checks factors such as CPU capacity, memory availability, node health, and scheduling rules. Based on this analysis, it selects the most suitable node and assign the pod to it. Then comes the controller manager. So controller manager. The controller manager is a component that runs multiple controllers responsible for maintaining cluster state. Okay, it continuously monitors the system and ensures that the actual state matches the desired state defined by the user. So for example, if the user specifies that 3 pods should always run and 1 crashes out of 3, now it's 2. So this controller detects the difference and automatically creates a new pod to restore the current number. Okay, I hope this one is also clear to you. Now these are the 4 important components of the control plane. Now we are going to move to worker node. So kubelet is the first component. It's an agent running on every node and it communicates with control plane and ensures that the pods assigned to the node are running correctly. It receives instructions from the API server and starts or stops containers as required. So directly communicates with the API server. The kubelet also constantly checks the health of the container and reports the status updates back to the control plane. It acts as an agent who takes care overall stuff happening in the worker node. Now comes the container runtime. We also have something as container runtime. So this one is the component that actually executes containers on the node. So Kubernetes does not directly run your containers. Instead, it relies on a runtime such as containerd is one of the example of container runtime to pull the container images and start containers and manage their life cycle. So again, we have another component called kubeproxy. This component acts as a networking component running on each node and it manages the network communication between services and pods. It maintains the network rules that allow traffic to reach the correct pod even if pods are created, destroyed, or moved between nodes. Okay, so this is the game changer when it comes to having multiple worker node. Okay, then comes our hero pod. This is the most influencing thing in Kubernetes. So the very basic definition for a pod is that the smallest deployable unit in Kubernetes. It represents a running instance of an application. A pod can contain one or more containers that work together to perform a specific function, and all the containers inside a pod share the same network address and storage resources, which allows them to communicate efficiently. So this pod has containers, okay, like this small containers of application containers. Pods are temporary by design. If a pod fails, Kubernetes can automatically create a new one to maintain the desired state. So for example, this one fails, Kubernetes is going to create another pod. Now comes the what is inside this pod. Okay, so inside this pod we have containers. So we have already seen that what is a container, but let me explain you again. A container is a lightweight runtime environment that packages an application along with its required dependencies such as libraries or configuration files. So these containers are run inside the pod. I hope all these components are very clear to you. Now I'm going to walk you through again so that you understand all these components with a flow, because at first it might feel overwhelming to know all these components, but when you actually follow a flow, you are going to understand each component and their roles in Kubernetes. So suppose there is a user. I'm really bad at drawing, but a user sends the request to deploy an application using kubectl. Okay, so we have an application for this one is a booking service. We want to deploy in Kubernetes. Okay, this is our requirement, basic requirement. We have an application and we need to deploy this in a Kubernetes cluster. So what is going to happen? What do you think? So this guy going to use Kubernetes command line tool and try to deploy it. The request of his deployment going to reach API server. Okay, and API server is going to validate and process it. After that, the desired configuration is going to be stored in the etcd. The scheduler that we have selects the best worker node to run the pod. So currently in the drawing that I have shown you, we have one worker node. Just replicate in your brain that we have multiple worker nodes. We can have multiple worker nodes for high availability. Okay, and we can also have multiple control plane nodes for highly availability. So we have another worker node wn2, wn1. Okay, so this one is 1, this one is 2. So the scheduler is going to decide whether it should actually deploy in worker node 1 or worker node 2, which pod. Then comes the kubelet. The kubelet on that node, when we call node, we are talking about worker node. Okay, in that node, so if for example take a scenario, the worker node, the scheduler selects worker node 2. So the kubelet of that node is going to receive the instructions from the control plane. Hey man, this control plane node. So control plane is going to communicate with the kubelet. Hey man, we have something to deploy, just proceed with it. Okay, then we know that we have a container runtime. Okay, so it's going to pull the container images and start the container inside a pod. What do I mean by pulling the images? Your image must be in some registry, either in the Docker registry, okay, or in some cloud registry. For example, if you are using GCP, so artifact registry, okay, somewhere your image must be there. So it's going to pull that image. Hey boss, give me the image of your application. What was the application name? Booking service, because I have to run this. And it pulls and starts the container inside the pod. Now who is left? We have seen the workflow and we have covered everyone. So who is left? If you can see, we are missing kubeproxy. This guy is left. His role is still pending. So what he is going to do? Kubeproxy is going to ensure that application receive the network traffic, because someone has to enable the networks. So when you develop an application, so it has to run in some port. Suppose if it is a Java based application, some port must be there which has to be open. So all this networking stuff is handled by kubeproxy. So now you have understood the flow. We wanted to deploy a kube booking service application. We use the command line interface of Kubernetes to give the instructions that we want to deploy. API server received it. It's stored in etcd. It uses scheduler to select the best worker node. The best worker node was worker node 2. Then it uses the kubelet. So this kubelet on the worker node sees that the pod is assigned to its node. Container runtime. Hey man, just pull the image and start the containers. And the containers started inside the pod, and kubeproxy is responsible for the network configuration inside the pod's containers so that they can communicate easily. So with this diagram, I'm going to show you what we have created. As I mentioned, the Kubernetes architecture, we have a control plane node we have seen. So let me just copy this. I guess I can do that as well. And if I somehow able to paste it here, so we are going to compare this diagram with what we have created. So we created one etcd. We have etcd here. We created a controller manager. We have a controller manager here in the control plane node. We created one scheduler. We have a scheduler here at this point. We have API server. We have API server. Okay, easily you can draw this. And we have a container runtime which is present here. I told you there can be multiple worker nodes and there can be multiple control plane for high availability, but for this diagram there is one control plane and 3 worker nodes. So we have kubelet in the control plane, we have container runtime, we have pods. So I guess this much is very sufficient for you to understand the complete architecture of Kubernetes, and I hope you can able to understand the architecture. Thank you for watching, and you can come to this website opensourcify.in and you can just go through these topics. We have everything already present for you as a note, but trust me, I'm going to make a video on everything from basic to advanced in Kubernetes if you prefer watching video, and because I will be telling you more information in the video compared to what I have written in the website as a note, and it's completely free. I'm not charging anything. Just go and read it. Thank you for watching. Subscribe to Tekneikos.